Alright, so today this lecture is based on the second Newton's law, which is sum of force equals to ma. Okay, so this is where we are now. So we've done all the course outcome number 5, which is able to describe the motion of a particle in terms of kinematics. So we've done the rectilinear motion and curvilinear motion, and now we are into the Newton's law of motion. So we will be dealing with the equation of motion in the rectangular and also normal and tangential coordinates. Okay, so we will be by the end of this and upcoming lecture, you should be able to apply the equation of motion in solving dynamics problems. Equation of motion usually consists of sum of force equals to ma. Alright, the first Newton's law, let me minimize this. Alright, the first Newton's law is a law of inertia, where an object will be at rest and remain as it is if the sum of force equals to 0, or state of equilibrium. So this is the focus when you are doing the static parts with Dr. Uy. Okay, sum of force equals to ma, and in this case sum of force equals to 0, so a, the acceleration, is also 0. So if the sum of force is non-zero, there comes the second Newton's law, which is sum of force equals to m, the mass, times a, the acceleration. Okay, so the acceleration, on the other, if you rearrange acceleration equals to sum of force divided by mass m. The Newton's third law, on the other hand, is the force of action and reaction between the two objects that are equal, collinear, and opposite. Okay, so if these two particles A and B collide, and they both will apply the same magnitude of force but at a total opposite direction. Alright, so second Newton's law, Sir Isaac Newton said that a particle acted upon by an unbalanced force F experiences an acceleration A that has the same direction as the force and the magnitude that is directly proportional to the force. So he is saying that if the force, sum of force, is not 0, the particle will experiences acceleration that has the same direction as the unbalanced force. Okay, and the magnitude of the force is directly proportional to the mass. So this is actually a mass. Sorry about that. Newton's second law of motion, mass m is a property of matter, and mass of the body is specified in kilogram. Okay, the weight is the force applied to mass due to gravity. The weight is calculated using the equation of motion F equals to ma. However, a, the acceleration, is substituted to g, the gravity, where g is 9.81. For equation of motion in rectangular coordinates, the procedure to tackle the questions and the problems are as shown here. So first you have to select the inertial coordinate system. In this case, either rectangular coordinate system or the normal tangential. Rectangular coordinate system are x, y, and z, and normal tangential is a normal or tangential. Secondly, you have to draw the free body diagram. You have to draw this free body diagram because in your quiz and the test, most of the marks depends on your free body diagram. If you have wrong free body diagram, you will not get the correct answer. So the free body diagram should show all the external, not internal, but external forces applied to the particle. and then you have to resolve those forces into components x, y, and z, or normal and tangential, like so. Okay, and then draw the kinetic diagram showing the particle's inertia force m times a. Resolve these vectors into its components. So if you have Fy, F resultant y equals to MAY, and F resultant x equals to MAX, and apply equation of motion F, sum of force F equals to MA in their scalar component form. And then identify the unknowns in the problem and solve them. Alright, so in some cases you might need to use kinematics, so you could use all these 6 equations. Just make sure you know how to use them. Okay, when a particle is moving relative to an inertial x, y, and z frame of reference, the sum of force F equals to MA is equals to this long equation, which is basically it says sum of force of x equals to MAX, sum of force of y equals to MAY, and sum of force of z equals to MAZ. So make sure you know how to divide those components I, j, k, x, y, and z. That is for the rectangular coordinates. For 2D problem, all you have to do is just to solve for 2 components. So sum of force of x equals to MAX, sum of force of y equals to MAY. So for the system involving many components, for example, you have a lot of masses into one system, so sum of force equals to sum of MIAI. Okay, and this also equals to the total mass times the acceleration at the center of gravity. Okay, and this is total mass. So, all right, let's take a look at the first example where we have this box pulled by a string, and the string has 400 Newton to it, and the string is located, is pulling at 30 degrees from the horizon. Okay, and it is also given the kinetic coefficient of friction equals to 30% or 0.3, and we need to determine the velocity of the crate at 3 seconds starting from rest. All right, okay, let me open this a little bit more bigger. I hope we can see it. All right, this is good. Okay, so what's the first step? First step is FBD. Very important. Okay, it's a free body diagram. So the box or the crate is pulled by 400 Newton, and that, okay, so that's the first external force. The second external force would be the weight of the box. Okay, the third external force is the friction. Okay, friction equals to mu k times n. Okay, and lastly is the normal force applied to the box by the floor. Okay, is there any more? Okay, I don't think there's more. All right, so from here you can divide those components. Let's start with in the x direction. Okay, in the x direction, so you have this is 30, you have 400 Newton, 400 times cosine 30 pointing to the right. What else? Okay, minus the friction, which is mu k times n. I think that's it, right? For the x direction equals to MA. Alright, let's call this the first equation. The second equation would be F equals to MA, but in the y direction. So y direction we have N plus 400 sine 30, okay, minus mg equals to MA. However, there is no movement on the y direction, so MAY equals to 0. Okay, from here we can solve for N, which is mg minus 400 sine 30 is 1/2. Okay, so what we have, mg is just 490.5, right? Because the mass here is 50, right? 50 times the 9.81 is 490.5. Okay, as shown here. Minus sine 30 is 1/2, so n equals to 290.5 Newton. Okay, and then from there we can solve for acceleration A here. Okay, so let's put this back to equation number 1. What we will have is 290.5 plus 400 cosine 30. So 400 cosine 30. Cosine 30 is basically square root of 3 divided by 2. Minus mu k is what's mu k? Is 30%, 0.3, and n is given to is calculated 290.5 goes to MA. Okay, M is 50. Alright, from there we can solve for A. Okay, A is 5.19 meter per second squared. Alright. Okay, let's take a look at the solution. So firstly, what we have to do is the free body diagram. So here is the look of free body diagram where there is a 490.5 Newton pointing to the downward, and normal force by the floor is pointing upward, and then there's 400 Newton to the 30 degrees to the right. Okay, so we set up two equation of motions in the x and the y directions, and then from there we can solve for NC. Okay, NC and also A. Okay, but the question was asking about what is the velocity, right? Determine the velocity of the crate at 3 seconds. So we get this constant acceleration, so we can use the kinematics to solve that. So we have u start from rest 0. A is 5.19 times what's the 3 seconds. So from there we can solve 15.6 meter per second. It should be easy enough for you, I think. Alright, let's move on for the second example. This is a little bit more challenging. Okay, I need a fresh paper. Okay, so there's a baggage truck. So this example is testing you about the thing I just said. So it says, I said second Newton's law equals to F sum of force equals to MA, right? However, this force is external. What does it mean by external? So that means by the name itself, the force applied is from the external source. Okay, and then that means the mass applied by the external source should relate to the mass here should relate to the mass applied by the external source. Okay, to show you that, let's go through this example. So we have a baggage truck like you see in the airport. Okay, so you have A, B, and C. Okay, so A is the engine, the one that's pulling these three, pulling the whole thing. This is shown as F equals to 160 T. Okay, if the truck starts from rest, so V not equal to 0, and also it's given the weight of the A. Sorry, the truck A is 3,600 Newton. Second one, the B is 2,200, and C, okay, C is 1,300 Newton. All right, so we need to determine the speed. Okay, find speed, and in 2 seconds at t equals to 2. And also we need to find the horizontal force acting on the coupling. Alright, so I'm just gonna find T, okay, the tension between the coupling A and B. Okay, since this is quite hard, let me okay, I hope everybody can see this. Alright, so firstly we have to find the speed at t equals to 2. Now we are looking to solve this, we should look at A, B, C as the whole system. Okay, what I mean by that, because of this equation, sum of force equals to ma, and F has to be external force. Okay, if I'm just looking at A as the whole system, the tension here would be the external force. Okay, let me draw the boundary. Okay, so this is the whole system. The whole system, that means our mass should be a total mass. So divided by G. Okay, so that is what it means by mass of the total system, of the whole system. So F equals to ma, and we need to find the speed at t equals to 2. So let's find the acceleration of whole system. Okay, in this case we have to do the free body diagram. Okay, this is A plus B plus C, and the external force is 160 T to the left. Do we have anything else? I don't think so, right? Okay, let's move it here. So sum of force equals to NA, so 160 T equals to M T times A. Okay, so that is your equation of motion. Okay, I'm sorry. Let's define Okay, we define positive going to the left because it is get pulled to the left, right? So define positive to the left, so we don't need to put a negative here. So as long as you are consistent with your convention, so you start with this convention plus to the to the left. So A equals to 160t divided by mt. Mt is this number. Let me run the number. Let me run the number through the okay. So I run the number and I got 723.75 for this. Okay, so this is the total mass. So acceleration would be 0.221 t. All right, then we need to find the speed. So since the acceleration is the function of time, so that means we need to integrate A, the acceleration. Okay, so from A equals to dv dt, dv equals to A dt, so we integrate both sides. Okay, still since it says it starts from rest, so it's from 0 to v and from 0 to t. Okay, so from here we can find the equation of motion. So v minus 0 equals to A is 0.221 t dt t 0, and then from there 0.221 t squared divided by 2 t 0. Okay, and then we can get, well, let's see, okay, t equals to 2. Okay, so it becomes 0.221 meter per second. So that would be the speed of the card, of the whole thing, A, B, and C. Okay, at t equals to 2. Oh, sorry. Not 0.221, 0.442 meter per second. All right. All right. Second question is finding the tension. Okay, finding the tension A and B. All right. Looking at this. So again, we have to make sure the force, sum of force here is external. So in this case, we can choose A as a one system instead of all three, because we want to convert the tension here. So we have initially we have A and B and C, right? But we want to know the tension here. So initially, if we take all three as a one system, this tension is internal force. However, we want to make this tension as an external force because we want to find T tension. So we have to cut this. So our new system would look like this: A, where there is a T, and also there is a 160 T. So the mass A has two external forces acting on it. Okay. All right. So again, plus to the right, sum of force equals to MA. So 160T minus T equals to M. Okay, M in this case is just 3600 divided by G. Okay, times A. So A is the acceleration that we already found, which is here, 0.221 T. So the T will be 160 T minus, what's that, 3600 divided by 9.81 is 366.9. A is 0.221 and T. All right. So does it ask the tension at t equals to 2. Horizontal force acting on the coupling between A and B at this instant. So at t equals to 2, alright, at t equals to 2, we just have to substitute that. 160 times 2 minus 0.221, 81.1 times 2 equals to, yeah, you can calculate that. Let me see, what does it equals to? Okay, equals to 157.8. Right. Okay, let's take a look at the solution. Okay. Alright, so as usual, we have to start with a free body diagram. So free body diagram shows the A is there is an external force going to the left, and it is hooked to to the B and C. Okay, all of them has different mass. Okay, so and then we have to consider all three vehicles, because we want to know the acceleration of all three vehicles as a one system. So that's why M in this case is total, M total. So we sum up all the mass, all the weight divided by 9.81 together, or the total mass. So we get A, the acceleration, equals to 0.221 t. Okay, and then so using kinematics, we should be able to find the velocity. So we integrate that and substitute t equals to 2, we got 0.442 meter per second. Alright, so to find the tension, we have to use the Fx equals to ma as well. However, we just consider the truck A as the whole system. So in this case, 160 t minus big T, the tension, okay, equals to ma. Okay, m is 3600 divided by 9.81, okay, times the acceleration 0.221 times 2. Okay, exactly what I have in here. All right, so what if we use B? Okay, what if we use B as the whole system? Because B also get pulled by the tension. Okay, so like this, B, we have T as the external force. However, there's also T2 by C. Okay, so we cannot use B, however, because we do not know T2. However, we can use B plus C as the whole system. So T, alright, so F equals to MA, going to the left as positive. Alright, so F equals to T equals to M. M in this case 2200 plus 1300 divided by 9.81 times A. A is 0.221 times 2. Okay, let's see if you could calculate this, if we could arrive at the same answer. Alright, I calculated using my calculator. I did get the same answer. Okay, in Newton. Okay, so as long as you choose the right system, you should be able to arrive to the correct answer. Okay, so in this case, the subsystem B and C get the tension as the external force, so we can use this equation. Okay, and also if we choose A, there are two external forces, 160 T and also T, the big T. So we plug that in, we get the same answer as well. Okay, I hope you get that. Alright, so let's move on to the normal and tangential coordinate for the equation of motion. So right here we have the similar case as the rectangular coordinate system, where we have three components as well. So we have FT, Fn, and Fb. Ft is tangential, which is in the direction of the tangent of the curve here, and the normal component is direction of the perpendicular to the tangent, but pointing to the center of radius of curvature, O here. And lastly, Fb is the perpendicular to both Fn and Ft plane. Okay. Right. Here are the procedures for analysis using the normal and tangential coordinates. So first you have to establish the initial T and N coordinate system at the particle and draw the particle's free body diagram. Secondly, normal acceleration AN always acts in the positive N direction. So please remember this. Okay, normal acceleration AN always acts on the positive N direction. Right? Make sure that your Fn, sum of Fn equals to MA, but the direction is towards the positive end, or towards the center of curvature. Okay, tangential acceleration AT is assumed in the positive T direction, tangent direction, and then identify the unknowns in the problem, and then apply the equation of motion in T and N and also Fb if needed. Kinetic, you can use the kinematics to solve using these three equations, and if the path is defined as y equals fx, you can figure out the rho using that long equation. Okay, let's take a look at this example. In this example, there is no number involved, so all you have to do is to rearrange the equation so that you could get the expression of the equation. So in this case, there's a banking angle theta, and the car is sitting on the ramp. Okay, first thing first is to write the equation of motion. Sorry, the question is asking what is the banking angle theta here, so that the car does not depend on the friction to prevent it sliding up or down of the track. Okay, so we need to find theta so that it won't slide down. And imagine this floor, this ramp is frictionless. Okay, on the other hand. Alright, so let's go ahead and write the free body diagram. So pointing down is mg, pointing perpendicular to the ramp is normal. Oops. Alright, there you go. Alright, so okay, so using the normal and tangential coordinate, so the car is moving like towards pointing outward from this paper right here. Alright, so N is pointing to the to the center of curvature. Right, let's go ahead and write the f equals to ma in n direction. Okay, the n direction would be, so theta here and theta would be there. Okay, so n hold on, let me see, n equals to, alright, sorry, I made a mistake. The n should be pointing perpendicularly there. Alright, so that's the normal, and this is the normal from normal reaction force from the ramp, and this is normal component, right? So going to the normal direction with the, this is a center of curvature, not here. So n, the big N, sine theta equals to, equals to an, from the previous lecture we know is basically v squared divided by rho, and that would be the first equation. Right, and then from there, right, so from there we can do another one, f equals to ma going up, which is n cosine theta minus mg equals to ma. However, there is no movement up and down, so this is 0. Alright, so n equals to mg divided by cosine theta as second equation. Right, put this into the first one. What we get is mg divided by cosine theta times sine theta equals to mv squared divided by rho. Right, so m and m can be cancelled out, and we have a tangent theta equals to gv squared divided by rho. So theta equals to inverse tangent gv squared divided by rho. Alright, so that is the answer. Okay, let's take a look at the solution. Okay, firstly, free body diagram. So we have NC pointing to the perpendicular of the ram, and AN going to the right, so there is no friction on the tire, and we do not know NC and theta. Okay, going to the right is NC sine theta equals to m v squared divided by rho, and going up is FB, which is the binomial component, binomial component, okay, going up, which is NC cosine theta minus mg. So I should have called it binomial right here, going up FB. Okay, we have FN and FB going up. Alright, so so NC cosine theta minus mg, and then solve these both, so we get v squared. Hold on, I think I got it a little I got it wrong. Yeah, I think I got it wrong, where the g here should have gone down here, so g there and g there. Alright, so theta equals to inverse tangent v squared divided by rho g. Okay, alright, let's move on to example number 4. Okay, this one, it involves some values. So in this case we have a ski guy again. Okay, it goes up and then down, and then at the point A, okay, since he will go up like this, our center of curvature would be up here, so our normal is going up, so we need to find determine the force, normal force, Fn, sorry, N, big N, and the acceleration. Okay, and also the mass is given 600 divided by G. Okay, and then the velocity A here is 9 meters per second. Okay, I think I got everything. Okay, let's take a look. Okay, free body diagram says all the external forces. Okay, so there is NC here, the normal force, and I think that's it. There's no friction, there's nothing. So using F equals to MA in the N direction. Okay, why is it pointing up? Because the pointing up positive direction is the positive direction of the normal. Okay, always remember that. Okay, so NC equals to mv squared divided by rho. Okay, and m is 600 divided by 9.81, v is 81, v squared is 81 divided by rho. Okay, and c equals to nc. Oh, equal divided I forgot about the mg though. Okay, let's do that again. Okay, always list all the external forces here. Okay, nc minus mg equals to mv squared divided by rho. So nc equals to mv squared is 81 divided by rho plus mg. Okay, mg is given, sorry, 600. Okay, equals to mv squared divided by rho. Oh, sorry done. So net ma. Okay, so I move the mg to the right side, and what we left here is this. Okay, so we can get everything. M is given here, however rho we do not know, so now we can use the long equation to solve for rho. Okay, because in the question we are given the equation of the ramp, so rho, and I hope you can remember this, which is 1 plus dy dx squared divided by second derivative of y. Alright, so rho is 1 plus, okay, let's take a look at the question. So we are given y equals to 1 over 60 x squared minus 15, so dy dx would be 160 x, okay, squared divided by second derivative of that would be 2 divided by 60. Alright, so x is located at, in this case, 15, negative, no, x equals to 0, so this comes to 0, right? So 1 divided by 260, so equals to 30. Let's see if that's right. Yeah, 30 meters. Okay, 30 meters. put that back here. Sorry, put the row back here. Okay, you get NC equals to 600 divided by 9.81 times 81, okay, divided by 30 plus 600. Okay, let's take a look. 600 times 81 divided by 9.81 divided by 30 plus 600. 765 Newton. Okay, that would be the normal force. Okay, and then we need to find A, the acceleration. So there's no acceleration to the tangent, but there's acceleration going up. In this case, AN is the only acceleration, which is v squared divided by rho. So rho is rho is 30 meters. So 81 divided by 30 meters is 2.7 meter per second squared. Okay, let's check our calculation with the solution. So firstly, of course, we have to do the free body diagram. So there is weight pointing downward, which is 600 Newton, and there's N, the normal force, going upward, and also the acceleration in the normal direction going upward as well. And there's a tangential acceleration going to the left, which is actually 0. Okay, so sum of force equals to MA in the N direction. We have NA minus the weight equals to 600 divided by 9.81, this is the mass, times 81, the v squared, divided by rho. And then for the tangential, part, the force is 0. There is no force there because the 600 divided by 9.01, 80. So this is nothing. You don't have to write that. Okay, and then we go along with the equation of motion, since we do not know rho here, to solve for NA. So rho equals to 30 meters, like I showed. And then so NA, the normal force is 765 from the calculation. Where it is? Okay, right here. Okay, that's what we got. And then using kinematics, the acceleration AN equals to v squared divided by rho, because AT equals to 0, and we get 2.7 meter per second squared. Right. And the acceleration, since AT is 0, the total acceleration at that point A is 2.7 meter per second squared. Alright, lastly, let's take a look at this previous exam question. You can please pause this video to take a look at the question, think about it, and try it yourself, and then we can go through the solution. Alright, let's start with the free body diagram. So we have T pointing this way. Okay, so this is a nice Pythagorean theorem triangle. We have 3, 4, and 5. All right, and then pointing downward is MG. Okay, and then we have a normal to the ramp. All right, so from there, it says that the surface is smooth and the mass is 0.2 kilogram, and the speed is 0.5 meter per second. determine the tension, this tension T of the cord, and the reaction which the cone exerts to the block, so which is N. So we need to find these two, T and N. Okay, other than that, I think, oh, this is 200 millimeters. Okay, let's try this. Let's try to solve this by our own. Okay, so we start with the free body diagram here, and we did get the weight pointing downward and also the tangent, and another one is the reaction normal force. And then using the similar triangle, we have 3, 4, and there's a 2 here. So we want to find what's the length here. So using 3, 5, so the whole thing is 5. Okay, 5 goes to 2. Sorry, we need to find here x. So x and 2. So x equals to 6 divided by 5. Okay, so let's say this is angle theta, like this, and then there will be theta here, and also theta right there. Okay, and we have theta equals to 3 and 4 and 5. Okay, this is our angle. We don't have to convert to sine or cosine because this is given like this. So 4, 3 and 5. Okay, okay, the normal force is pointing to the center of the cone, small n. Let's go ahead and do that. MAN. So we have negative is pointing to the left because our center of curvature is at the center of the cone. So N, let's see, 4 divided by 5, right, plus tension, that would be 3. Okay, so here's the, ooh, I didn't realize you didn't see it. I'm so sorry about that. So N component to the left is negative N 4 divided by 5 by using the trigonometry here, and here is 3, right? So 3 plus 3 divided by 5. Is there any more? No, there's no more. External force M V squared divided by rho, because this is AN. AN. So what's okay? M is given, V is given, so we have N and T as unknown. So we need another equation. All right. So let's call this equation number 1. Okay, equation number 2, that will be F equals to MA on B. Okay, in binomial. So binomial pointing upward is N 3, 5 minus mg plus T 4, 5. That's it, right? There's nothing else going upward or downward. Yeah, I think so. Equals to MA equals to 0. So there's no movement going up. So this is 0. Alright, so from there we can calculate, we can find the N in terms of T. So 4 divided by 5T plus mg. M is 0.2 g. Okay. Oh, times 5 divided by 3. I think I got it right, I hope. Alright, so that's N. And then what else? After we got n, we need to put it back to the first equation right there. In this case, negative 4 divided by 5t plus 0.2 g 3, right? So, and then 5 plus t 5 m is 0.2, v is 0.5 squared divided by rho we got it here is 6 divided by 5. Okay, and then we can solve for t. Okay, this is quite a lot. T 3.5 minus 12 point divided by 5. Okay, and then let me see if I got it right. Four times 4, 16. Okay, let me just do it slowly. Negative 5t plus 0.2 g 4 divided by 3 plus 5t equals to, okay, let's do that, 0.5 5 0.2 divided by 6 0.042. Okay, let's put t outside, so we have 3.5 minus 16 divided by 15. That looks okay. Equals to 0.042 plus 0.8 g divided by 3. Yeah, so t equals to t equals to 2.658 divided by 9 minus 16, negative 7 divided by 15. Okay, 2.658 divided by 7 times 15, 5.7. I'm not sure if that's right. Okay, let's take a look at the solution. Okay, in this example, t is ultimately a particle rotating in a circle with radius rho. So rho we can calculate using the similar triangle right here. Let me enlarge that. Okay, so that is rho. Thus the n component is pointing into the center, so t component is pointing out of the free body diagram, and b, the binomial component, is pointing upward. So using this free body diagram, so you got the radius of curvature as 6 divided by 5, or 0.12. Okay, and then write the equation of motion in the normal direction. So I think I got it right for the normal. Okay, 3.5t minus n 4.4 divided by 5, okay, 0.2 v squared divided by rho 0.12, okay, and then t 45, yeah, and then nb plus mb, okay, plus nb 3.5, yep, and minus mg, yeah, mg, okay, equals to 0. Yeah, I got it right. So t equals to, so something wrong in my whole calculation right here, but if you do the calculation right, the algebra right, you should be able to get T, the tension, equals to 1.82 Newton, and NB, the normal force, is 0.844. Alright, so I highly encourage you to do this on your own and try to check yourself your answer with this solution. Okay, and let's go on for the summary and we are done. Thank you so much.